Here, now we'll be continuing on to the next question, that is from the Leetcode graph playlist card, that is number of closed islands 1 to 54. And the question statement is, given a 2D grid consisting of zeros and ones, zeros representing land and one representing water, it's just the opposite. An island is a maximal four directionally connected group of zeros, and closed island is an island totally surrounded by ones. So, what is this telling us? It just has been reversed. That means previously we were considering one as land, here we are considering zero as land. Okay, and what have they said? They have said we need to find islands. And by the way, if you are new to this channel and you are stumbled upon this video, I've already made this videos on these three. Okay, and this is a playlist that will be going on. Please do check that out if you have any doubt as well. Okay, and it will be cleared since this is a playlist from day 1 till day 40. Fine. And so coming on to the question part as well, we see that zeros are considered as land, and they have said that all the zeros should be surrounded by one. One mean water. Fine. This is the only thing that you need to find, and you just have to tell the number of islands. Okay. So you will be thinking that okay, it is very simple, and it is exactly similar to the number of island problem. Yes, it is exactly similar to the number of island problem. The only thing that has changed is ones and zeros. So the rules have been reversed. Zero is the island and one is water. And mind you, they have said that these surrounding out of boundary cases are not actually water. And what do we mean by that? That means, see, here is an island, this is an island, this is an island, this is an island. Okay, it is surrounded by water from here and here. Why can we not consider this as an island? So they have said if you are going out of boundary, it is not actually water. And what do we mean by that? The out of boundary cases are not considered as water. Previously, in number of island, they had said that the boundaries means it is covered by water only. Okay, but here we are saying that it should be exactly covered by ones. Okay, but not out of boundary cases. So that means if there is an island present in the edge, okay, in the edge of the matrix, all the edges, it will not be valid because it is not covered by ones in any of the side. Why so? See, if there is a zero present here, think that it is covered by one on top, right, and down also, but on the left it will not be covered, right, because it is out of bound of the matrix and we will not have anything. So that is the only special case that you need to take care of in this question. And if you have been following the playlist, it will be an easy cakewalk question for you again. Here we are again going to use BFS, and there is no such thing about BFS. You can use DFS also. That is just your own preference. Okay. And what we do here is, this is a simple BFS code again, and the prerequisite is obviously BFS in order to know this. So coming on to this question, again, how we are going to do it? We are just following the same pattern. That is, we will go at every single cell and we will try to see if it is a zero. Again, don't try to get confused. Okay, zero here is land and one here is water. So that is the only thing. So we'll start from zero. If it is a zero, we'll try to BFS in all the four direction. Okay, all the four direction will try to BFS. And mind you, the only thing that we need to take care of is that we do not stumble upon the edges. That means, let's just say if this is also zero, if this is also zero, that means this whole thing is an island, this is also an island, and these things are also an island. So this island actually becomes a part of the whole thing. Everything is covered by one, that is fine, but this part, the out of bounds, the last island or the last place is not covered by one, right? So we just only need to take care of that position, that is we are not stumbling upon the boundary cases. So that is where this algorithm helps. Let's see how we are going to do it. So we have maintained a queue, simple queue, okay, which is used in BFS. After that, I said that we will be starting our BFS from every position where we have a land that is represented by zero. And what is this bound doing? Bound is doing what? See, as I said and mentioned earlier as well, we do not care about the edge. Okay, we do not care about the edges, so we'll be simply ignoring that. So I have actually made a function here which will say that is it actually an edge or not. So if it is at any of the edges, what will I say? That we cannot do it. But if it is not at the edges, we'll return a true. That means we can go and actually form an island. Now coming on to the BFS part. Now BFS says that okay, we also need a visited array, but I have actually just change the values from 0 to 2 in order to not actually take any other matrix for actually the visited part. Okay, so you can also take a visited array also, so you can do it anyway, but I have actually changed the values from the grid only to not actually take any other uh, data structure to maintain a visited array. We now go on to the queue. We pop out of the queue. Now again, this part right here, why we are moving on the 4 direction, why do we have dx dy? Do check out the uh, this question, that is number of island. I've explained why do we do that, and if you have been following the playlist, it will be a easy thing for you and you'll understand why it is there. So this is just my next position where I will be going. Now I need to check that is it actually in my boundary or not. So this is the boundary case that I am saying that okay, is it actually a possible value or a possible index that we can move on to. Okay, I could also have written it in a much better way by actually using it in a function, but I have directly written it here. Okay, and after that I'm saying that okay, this is a valid position where I'm going to, but is that a land that I'm going on to? You also need to check that as well. That means see, coming on to this example only, we are right here. Fine. If we want to move right, can we move right? Obviously not. Why so? Because it is a water, right? It is water, we cannot move to the water, we can only move to the land part, right? So that is why I maintained a value here saying that wherever I am going next, is it also an island? If it is an island, we jump onto that island and we mark that island as visited and we push it into our queue. Now we also want to check it that is that a edge value or not. This bound condition that we wrote earlier was a function saying that okay, is it actually an edge, which we cannot take obviously, right? So why so? Let's see. If we have some test case where it says that this is also 0, this is also 0, and this is also 0. Okay, let's just say you are right here, you'll try to go right. Okay, this could be a possible island, but is it? Obviously not. As I explained you while explaining the question, it cannot be a valid island because there is no surrounding water. This is not a surrounding water, there is nothing to the right of it, right? So that is why this cannot be a possible value. So this is where this bound condition will come into play. It will say that okay, if and only if this bound condition is not true, that means it is not on the edge, our new island is not on the edge, then only we can go and place ourselves there. Okay, so that is where this bound condition comes into play. And if it is actually an edge, what we can say that I have actually landed upon a boundary island and this cannot be added to my answer, right? So this is where I've just maintained a found value which will say that if I am actually on a place where it is not to be needed, that means I'm not on an edge, I will just increment my value by this. And if I'm onto the edge, I will not increment my value. Okay, so this is the part where this found is actually taking care of. And at the end of the day, we will just return our count value, which is saying that okay, these are the number of possible islands. And this is the whole code, it will be linked into the description as well. And if you still have any doubt, please do ask me in the comments, I'll be clarifying that as well. Feel free to ask me any doubt regarding to this question as well. Okay, and do check out the previous videos, that will help you to understand this question better. Okay, because these three questions are almost similar to each of them. Okay, they are exactly, not exactly, but almost 80 to 90% I could say they are similar only. Okay, so do check that out, then you'll understand this part better. Fine. And yeah, this is it for this video. If you did understand this question, the explanation and the code as well, please do like and subscribe. And yeah, thank you for watching.